Hello, folks. Welcome to Learn Synthesis with Pure Data, Series 1, Episode 9. Today we're going to look at amplitude modulation as far as tremolo is concerned. And away we go. Okay, so we're going to look at amplitude modulation today and finally use that oscillator module called AmpMod that we've been kind of leaving to the side there. And we'll also take a look at what ring modulation is because they're both related. But in our synthesizer, we'll primarily be using this as a tremolo effect. So you can see how we do that. So anyway, let me get my screen here. Okay, so this is where we've left off. Now, what I'm going to do is just reorder things here a little bit. I'm going to move this module up here temporarily, a little bit off screen. And then I'm going to put it back down here. Now, this is not necessarily required, but it's actually a good idea because it makes more sense. Typically, when you make a synthesizer like this that is modular, meaning these subpatches that we make are like modules, components of the overall synthesizer. It's good to have like some sort of logical order to them. Here, I'm just trying to even that out a little bit. Later, when I do add some colors and graphic user interface niceties to this, it'll be easier to see things. Everything's just a little black and white right now. But in any case, this is where our signal's starting. Well, MIDI comes in here. Then here's where our signal starts. It goes to the filter. And then we're going to have it go to here next, and then to the amplitude envelope. So it's kind of nice to have that in order look. Typically, when people are looking at the interface of a synthesizer, you'll have orders that are like top down, left, right. That's usually the way things go. So eventually, as I've been hinting at, that we're going to duplicate these components and have another set of them down here, going left to right in order just makes more sense. So anyway, now what we're going to do is look at what the output is here in the filter. I think it's called filter underscore 1 underscore out. Yep. And right now we have it going straight into the envelope, the ADSR. You see filter underscore 1 underscore out. I'm going to change this because we're going to have an amp mod out. We'll call it amp underscore mod underscore 1 underscore out. Okay, we didn't make it yet, but we're going to. It's going to be in this amp mod. And another thing I should probably do, let me see if it lets me type this in here. Amp mod underscore 1. Yep, I was able to select the name of this and add the 1 to it. Because there's actually, like I said, we're going to duplicate these modules and have them down here. But in order to successfully duplicate them and make it a convenient way to kind of like copy and paste them down, we need to distinguish between this row that will be oscillator 1, filter 1, amp mod 1, ADSR 1, and then the second row, which will be the twos. So we need to start make sure we have those distinctions made now. You see how like table names and the sends and receives are all including ones in them. Now that's one thing that we're going to actually have to do here, I believe. Yeah, look at this. All these sends and receives here. The messages and everything are going to have ones in them. So let's start going through. I'm basically going to start upper left, go down and work my way over and hopefully not miss anything. We probably do have send and receive symbols here for this. And so I'm going to look at them. Amp mod 1 wave, with the 1 underscore. Now it's important when you do this that you do it accurately. In fact, what I might be able to do to make it a little bit quicker, select the underscore and the 1. Just that. Let me zoom in and make sure I did select it. Okay, so I have 1 and underscore. I'm hitting Control C, Command C in Mac, so we can copy and paste that around, because that'll be a common name change for all these things. Amp mod wave here. Now let me see here. This is amp mod 1 wave send. Okay. And the table is named amp mod wave. We want to rename it to amp mod 1 wave. So if I click the cursor there, hit Control V, Command V in Mac, we pasted the 1 underscore in there. So now that's been renamed. Now it's not running now because its name's changed and we haven't changed the name of the tab right that is telling it to do that. So anyway, here we're going to need to change these, all these here, these receives. We're going to add the 1 underscore to that. Here's the table name. We want it to be amp mod underscore 1 underscore wave. So I'm pasting the 1 underscore in. This receive needs to be renamed. Okay. And these, there's no sends and receives there. Okay, I'm just looking this over here. Because eventually this is going to be duplicated. And just trust me, by doing this, when we duplicate it later to make that second row of modules for the synthesizer, it'll make life much easier on us. Oh, hold on. I pasted this one wrong, didn't I? Yeah, it's amp mod underscore 1 underscore, then the rest of the name. So let me fix that. Amp mod 1. Oh, yeah, and I need to fix this too. See, you got to be careful with these. I'm trying to save time by copying and pasting it in, but if you don't do it right, things don't send. Because the names need to match. And that's why I try to keep my names kind of consistent. Okay, and then down here, same thing. Got to be careful. Get them right. There we are. Now, I think that's everything. This is how we're going to test it. Let me switch through these. I don't see the wave shapes changing. So, oh, wait a minute. Did I rename this? No, I did not. 1 underscore. This is a receive from here. So there we go. The wave shapes are changing. Everything's within the table. We're fine. Remember, we're not hearing anything yet. We took the DAC out of here. Now let me make sure these error messages have something to do with what we've been doing. No matching send. Yeah, this just happened when I was renaming things. So those errors are understandable. Now we do have a load bang here to make sure these are set up correctly. We're going to keep that in. But what we're going to do is the following. I'm going to disconnect these cables. This is going to modulate amplitude, which means our signal is going to come in through here. And then it's going to be changed, and it will basically rise and fall in amplitude with the shape in the table as time goes on. So we need an amplifier for that. I'm going to make a star tilde. Oh, it made the object down here. There we go. Star tilde. Now, I am going to set this up one way, and then you'll notice an issue that it'll have, and then I'm going to fix that issue. But I just want you to see it because it's good to kind of like know about. It's one thing that is a specific concern or a thing that needs to be dealt with when doing amplitude modulation. So anyway, so this is going to receive sound signal in, and that sound signal will go to the tab right. We won't see anything displayed just yet because there is no signal for this stuff to be multiplied by yet. But we need to make an output. And remember, send tilde, S tilde, amp underscore mod underscore 1 underscore out. That's what we have coming into the ADSR. We just made that before we opened up this subpatch. So this is going to send our signal out from here and go into the ADSR module, which is right next to it. This one right here that we just edited. Now, we're going to want to receive the signal in from here, from our filter that we made last week. That means we want to receive an R tilde because we're receiving audio signal. Filter underscore 1 underscore out is its name. So we'll hook that up down here. And remember, we are going to actually do some adjustments to this later. But I want you to hear what we get and then see why we make those adjustments. Now let me see here. Receive amp mod 1 out. Those no matching send. Come on, move up. Yeah, it should be. This is a send, not a receive. Oh, it's the one in the other patch. Now that we made this, we're good. Just like to always double check those errors. But what I'll do after I finish is I'll close this up, open up the patch again, and test it out. Always want to do that. Now, let's just click these things, make sure all this stuff has been sent in. Yeah, I didn't even need to do this. We're hearing sound. The signal's coming through here, but it's getting multiplied by the signals coming out of these guys. And it's being written to the table, but it's not quite working right because we got to give these guys different frequencies. What we're hearing right now is actually ring modulation, which is a form of amplitude modulation. You see how each of these waveforms, whichever one I select, right now the sine wave is what's selected. So this sine wave is oscillating at 440 hertz. That means the signal's coming through, and we're taking its amplitude and we're moving it up and down at 440 hertz. That is a little bit fast. And that's why the sound actually sounds a little more complex. You hear this note? You hear, and you hear some other pitches in it. And the thing is, it's a sine wave, which means it really should be just a pure frequency. 440 should be all we hear. But we're hearing more because it's creating what's called sidebands. Because the amplitude is being modulated so fast, it creates some other kind of like ghost frequencies within the sound. This is a way to kind of like richen up sound, and ring modulation is basically when you modulate amplitude at a speed usually above 20, maybe above 40, basically at rates of frequencies that would normally be audible. Like if you play a 440 hertz sine tone, you can hear a note. So it could be 1,000, it could be all sorts of frequency values, just as long as they're above something like 40, you'll get the effect of ring modulation. But if you slow this down, you're going to get different results. And in fact, what we're going to do is make something here so that we can actually change what frequency is happening from all of these. Well, let me see here. I'm going to try to create a little more room here. Let's select these, move these down. That should give me enough room. I'll move this one down in comparison. And same thing here. Okay. And what we're going to do is put in 2 number boxes. And we're going to use the variety called the number 2 box, which in the put menu is here. Shift Control N or Shift Command N in Mac. Because later we may want to color these, and these number boxes let you do that. We're going to give it a send symbol. We'll call this amp underscore mod underscore 1 underscore freq FREQ underscore send. I'm going to do the receive in a similar manner. Amp mod 1 or freq RECV. Alrighty. And the width of 5 digits is fine. I'm going to give it the label F so we don't take up too much space. And I'm going to, let's see, its height. Well, let's see how much room we have over here. Don't have much room. And in fact, we're going to try and make sure that F displays a little bit to the left of it. So I'm going to hit the apply button here. So we see the F label come up, but it's crashing into the thing above. So we want to move this label to the left of the number box. And I'm going to estimate here that our X, here, this is for the label, the X value for it, let's do a negative 17, I think is what I used to use for labels like this. And then its Y offset is actually going to be a positive value. Oh, no. That's the one that's going to be 17. Well, let's do both at 17 and see where that F ends up. Way over here. Okay, yeah, so its X is way off. Maybe it's 7 for both of these. But negative 7 here. And see if that ends up where we want it. It could be a little lower. Maybe. Let me zoom in. Actually, that's pretty good. Maybe just a little bit more to the left. Let's do negative 10. 3 more pixels over. There we go. This is where we're going to basically control the frequency. So this is going to control the frequency of these oscillators. So you can just type it in. And then I'm going to select this and duplicate it. Control D. Just so I don't have to make another one of the same type. Oh, and you know what? Actually, no, I'm going to make a slider for that. Make a horizontal slider. Control-Shift-J or Command-Shift-J in Mac. And what we're going to do is make this an amount slider. Because what you need to do is, in a waveform, right now you see this is just kind of like bubbling up and down. It's like a really small sine wave. That's because we're not giving it much amount or amplitude to this oscillator. This is going to control that. We're going to give it 0 to 1 range. And I'm going to make its width 100. Let's see if that fits in here all right. The physical width of it is not super important, other than fitting it in the box, which I want to do. So now let me cut that in half and make it about 50 wide. And this is going to be amount. I could just put A there. Most people in synthesis, when they see 2 sliders on an amplitude modulating oscillator, are going to be like, all right, that's frequency and amount. So we're speaking the language. There, I'm moving that label. Hit apply. There we go. This patch cable that's in the way is going to be hidden on the outside. Patch cables get hidden. Now this amount of negative 10 is not enough. Let's do 17. Maybe that's a little too far. So we'll do 14. That looks pretty good. We can make this a little wider because, actually the wider, the better, because then the more of a resolution of selecting values that you have. So let's try 60. Looks like about 10 pixels will be the right amount for that. Yeah, there we go. All right, and then over here, its send symbol will be amp mod 1 amount send. And its receive will be amp mod 1 amount RECV. We can hit OK. Alrighty. Now, actually, come to think of it, I'm going to change some things around here a little bit. Well, hold on. Yeah. Actually, I'm going to disconnect this for now. Right now, let's just get our signal from this oscillator here, and we'll have it display here. Now, the thing that we're going to need to do is actually do a little math first. I'm disconnecting these. Okay. Yeah. All right, so first of all, let's receive our frequency. So we're going to receive amp mod 1 FREQ. Boy, I hit enter there and screwed up that object I was making. Amp mod REQ send. Alrighty. Now this is going to go to all 4 of these. Now the thing is, as we change frequencies, to avoid that snapping sound, remember artifacts, we're going to use our old friend pack F50 and line tilde to smooth out the change of frequency. And likewise, we are not going to want the default of 440 hertz anymore. Don't really need defaults for any of these oscillators anymore. We'll use our load bang above to send any defaults that we need. They're already hooked up, in fact, for the phases. You see how we have our initial phase sent to the pulse wave, so it becomes a square wave, which is right here. And the one that I had just pointed to before inadvertently, yeah, that's a triangle wave, which we need the 2 halves of it in phase. So, and actually, yeah, the one for the pulse wave isn't actually phase. It's the 0.5 to make sure it's a square wave to start. Okay, so anyway, those defaults are being sent. The defaults to turn the table on is being sent, and the 0 is being sent here. Now, this is going to start off as an empty 0, which, believe it or not, is fine, because you don't necessarily want the amplitude modulation on when the synthesizer patch opens. Just when you want to add amplitude modulation. But we need to hook these up so that when the frequency gets changed, it'll change it for all the oscillators. There we go. And let me just move these up so it's clear what's going to what. Okay, so now these are going to get their amplitude, the frequency. And then now we want to be able to provide them with the amplitude, which is going to go down in here. So let me move. I'm going to disconnect this from this, but keep it connected here, because what we visually want to see here is the actual display of our amplitude modulation, which is basically the effect or the adjustment of amplitude on the main audio signal. So in that case, what we're going to want to do is hook up all these amplifiers here to the left inlet of this amplifier down here. Because that's what we're going to want to see displayed, is what this amplitude modulation is doing. Now, all these are hooked up to the left inlet, so be careful about that. Make sure they're all in the left inlet. The right inlet is going to be used to receive our amount here, because this amount is basically the amplitude of this oscillator, which is a range of 0 to 1. Now, the thing that's going to happen, though, you see how we have a center line here when there's silence? When we add this amplitude to here, it's going to go up and down, above and below this. And since this is going to be modulating the amplitude of an oscillator, we're actually going to want to change it to go to 0 to 1 rather than 1 down to -1. And I'll show you why, because we're going to actually just hook it up and you'll see why. Receive amp mod 1 amount send. Okay. Now let's use our old friend pack F50 so we get smooth adjustments here. And this goes in the right inlet here, because this is the amplitude of the amplitude modulating oscillator, which you can also consider to be its amount, because it really ends up being the amount to which it's modulating amplitude. Okay. Now, just to hear it, so we can kind of like talk about this further, I'm going to take this signal here. Let's make another star tilde, another amplifier. I take this signal here. Because remember, overall, what we want to do is take our sound signal that's coming through and modulate its amplitude. And that's what we do with the star tilde. Okay. And then we take the output from here, go into there. Now, if you were to take the output from this and go into tab right, you would see sound signal being modulated. Maybe you want that, or maybe you just want to see what this is doing. I could show you both just to kind of like make that clear. But anyway, let's give a frequency of like 2. I'm in run mode now, so I can type into the number box. And we'll turn this slider up halfway. I'm going to play a note. Okay, now our frequency is low here. Let's turn this up. Something is not quite right. I should be hearing like a whoa, 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 whoa sound. Amp mod 1 freq send. Are we getting frequency? Yeah. Coming in here, pack F50, line, tilde. Going into the frequency side of each of these. They're going into here. And we do have an amount. I've turned it all the way up. Let's make sure this is the correct range. 0 to 1. I want to visualize something else. I want to see my sound signal. Here's another thing I'm going to do, just for the heck of it. Because we have a filter here. Well, the frequency's all the way up. Yeah, this shouldn't be hurting it. But yeah, the amplitude is looking pretty low. That's one thing. And I'm not hearing it changing. Let's say, for example, we're on sine wave. Frequency comes in here. And it's at like 3, which should be fine for amplitude modulation. Fine, send, yeah. Let's just switch here, just to make sure. Amp mod 1 amount send. Let's make sure that's correct here. Hold on here. Is that? I had a C there instead of it. No, it is a D. Cutting off part of the letter so it looks like a C. Yeah, but no, I'm typing D. Just kind of off screen or out of the box there. That's correct. Until date amp underscore mod underscore 1 underscore out. Let's make sure that's over here. Oh, here I have it. Yeah, no, that's correct. Let's see. Well, our amount is working because when I put it down to 0, it does shut it off. That's something we're going to adjust in a moment, but first I want to get to the point where I'm actually hearing it fluctuate up and down. Well, first of all, yeah, I should really have this fluctuating just between 0 and 1. So let's do that first. Because right now, as you see, I want to see this oscillator only, so I am going to hook it up to here again. And what I'm seeing is really nothing in there, which is kind of bizarre. You should see some line in there. Amount 0, 1. Alrighty. But anyway, since this is normally just going to oscillate between -1 and +1, I want to take all these with all their math in it already done for their wave shapes and make sure that what they're oscillating between is 0 and 1, not going down to -1. So in order to do that, we're going to multiply the, well, actually, this is what we're going to do. We're going to disconnect these again, sorry. But just to make it clear, we're going to put them all through some math here. First of all, to make them go from 0 to 1, we need to multiply these audio signals by 0.5. That will have them oscillating only halfway what they're doing right now. Here, since this is the one we're trying out, let's just hook it up and see. I should see some movement there. I'm not seeing it. Well, that's a triangle wave. That's why I'm not seeing it. The sine wave is the one that's turned on. I have to hook up the triangle wave next anyway, so let's do that. Okay. Yeah, I should be seeing this oscillate. It's a low frequency, but should still see this going up and down, like between here and here. These are hooked up again. And we are on the first one, right? There's triangle. I'm hearing sound. I'm only seeing it sit down there. The tab right is on, correct? Yeah. I mean, the Metro is banging it. Interesting. Usually when I get stuck on something like this, whatever it is just something, ugh. Let's try the other shapes. Don't see anything. Now, these amp mod 1 underscore sign on off. Let's make sure everything is set right over here. All right, this should be giving us the sine wave. Now, I don't see it in here. It's not in the table at all. This should have received the 1 to be on. I'm hearing sound, so it's getting through. Is the speed of the Metro fast enough? I've done this before, and Metro 100's been fast enough. Tab right, amp mod 1 wave. Yep. Well, I have this one going through 0.5. Let's continue with this math here. Actually, all of these are going to need to go through this. So yeah, let me disconnect these. I don't know why I connected them back down there again. But yeah, we're cutting them in half. And then plus tilde 0.5, which will put them in a range of 0 to 1. Connect that up there. Let's connect you up there as well. Since we're on sine right now, we should see it. Yeah, let's make it like 440 hertz. When I go to 0, yeah. And as I move this up, this kind of goes out of range. See how that center line's moving up? That is bizarre. Let me look at the table properties. First of all, I want it to display vertically just between 0 and positive 1. So 1 here to 0. Let's hit apply. Okay. So there it's going down to the bottom as 0 amplitude. Here it's going up to the top at 1 amplitude. It's actually going further than that. Look at that. It's going all the way up here, which is weird. Somehow we're not getting the sine wave shape through there correctly. Let me see here. There's no, I took out the default frequencies. This frequency should be coming in. Amp mod 1 freq send. Here, I'm going to make a number box. I thought I checked the label, the symbol, and it works fine, but let me just double check it here. So look, this number is not getting from the number box to here. So obviously the symbol is wrong. So let's go to its properties. Amp underscore mod underscore one underscore free underscore send. Let's just copy and paste that in. Receive amp underscore mod underscore free underscore send. There we go. I still didn't even see what the typo was, but there was one there. Now, okay. Now, obviously, we're not in the box. Here, let's go to 0. That shuts off sound. We don't want that. We'll eventually fix that. But you see, as I increase amplitude, look at that. It's going well outside. So, obviously, our math is not quite right here. Amp mod sign on off. That's for turning on and off this thing. Underscore one underscore sign on off. Let's turn it off, turn it back on. Now I'm taking this signal. Oh, wait a minute. This is not hooked up to these. This is where I'm putting it in range. There we go. Now you see it's going between 0 and 1. All right. Now the thing is, let's put it on a frequency of 2 and play a note. There we go. That's our tremolo, where amplitude is rising and falling from 0 to 1. Or it could be less. But now you see how it goes off when you turn it off, and it also gets quieter when you turn the amount down. You want this to be the amount of tremolo. You don't want it to be turning it off. You just want it to be reducing tremolo, which is the modulation of amplitude at slower speeds. It's ring modulation at higher speeds. So you don't want it to be turning off, though. So we're going to actually fix that. But right now that I hooked these up, let's hear them. That should be a different shape. Yeah, the square wave's going to sound like that because that's literally going from 0 to 1, and it's going to snap. And that's the sawtooth where it's rising. Well, it's jumping up and then falling down. So that sounds like that. Maybe I can eliminate some of those. No, those are the actual shapes of those waveforms. So they are going to give you that effect with the snap in it. But now what I want to do is basically have the amount control how much is being tremoloed and how much is not being tremoloed. So what we're going to really do is have amount control the amount of this signal versus regular signal, meaning untremoloed signal. So what we're going to do that is the following. I'm going to copy this stuff, Command D or Control D, to duplicate this. And what we're going to do is have this be the inverse of this. So basically, as the amount goes up to 1 or down to 0, you'll get the opposite here. The output from here needs to be inverted. And remember, the way we do that is using swap 1. And then we create a minus sign. So what we get is on this side, when the amount's at 1, it's 0 over here. When it's 1 over here, it's 0 over here. This is the amplitude modulation. This is not. This is the signal without it. So when you turn the amount up on the amplitude modulation, the amount of signal without the modulation will go down. When you turn up the amount of the signal, when you turn down the amount of amplitude modulation, the amount of the non-modulated signal will go up. So that way the non-modulated signal will come through. So I made a plus tilde here to mix this signal, which is unmodulated, with this signal that is modulated. So you get the mix of the two. Now, what comes out of this plus is going to go here. Now, what do we want to visualize? I guess we'll visualize the signal out of the plus. So that way you can see if it's modulating or not and how much it is. Okay, now the thing is, since we haven't moved any of these numbers, since hooking that up, we actually need to do them again. Oops. Give me the opposite. Okay, we need to check something out here. What the heck? I'm not hearing it now. All right, I did something wrong here. Let me figure out what it is. Swap 1. Sure. That is a minus. Oh, wait a minute. This is not a plus tilde. Oh, wait a minute, wait. No, that's right. There it is supposed to be a star tilde. Here's the plus tilde down here. let's do something here. I'm going to disconnect this temporarily and connect this down here. Let's see if we're hearing. I turn up the amount here. I'm not hearing it anymore. Why am I not hearing this anymore? You were hearing it before. This is silly. Okay. This was just working a moment ago. Well, yeah, I know. Oh, yeah. I do kind of know what's going on here. Okay. I know what I need to do. Yep. Star tilde. We need to be taking this signal here, putting in the right inlet of an amplifier, and taking our sound signal here and putting through it. Just like we have, I'll show you, down here, the sound signal coming in where it's not being modulated, but it's going through an amplifier. We need to put this through an amplifier here. Basically, the amplitude modulation signal was not being applied to the sound signal. So now that it is, I can mix the two together with the plus, and there we go. Alrighty, so to make it faster by turning up the frequency, turn the amount down, and the amount of amplitude modulation goes down, but the signal doesn't stop. It's just not modulating. There we go. That's what we want. There we go. We now have control over amplitude modulation. Now I'm going to close this window, save here, and I'm going to type in a higher number. Let's just say like 500 and turn up the amount. That's when you'll get an effect like that where sidebands are created. But you know what would really be cool? And I just thought of this. It would be nicer to have this over here so that if you use a higher frequency like that where you get ring modulation and sidebands, it would be nice to then be able to sculpt that with our filter. Because now that we're getting more content, frequency content here, we can filter it. So what I need to do is change the sends here. So this is receiving OSC1 out. So we go up here. OSC_1 out. And this is going to go then This is called amp mod out. Amp mod 1 out, that's fine. So here's where we want to receive that. Oh, wait a minute. Here's where the sound's coming through. So instead of OSC1 out, we want amp mod 1 out. Okay, and then over here, this will receive from the filter. Filter underscore 1 underscore out. Okay, now, like right now, it's on a sine wave, and normally our filter would only not do much with the sine wave, just maybe make it louder. But if we can add sidebands to it, 500, turn up the amount, we could kind of filter those sidebands a bit. Not to mention if we use a different oscillator shape here. Let's try 4,000. So now it gives us more possibilities because we can filter the ring modulation effect here. But if we turn the amount down, then you hear it without the ring modulation because the amount is all the way down. Now the display here isn't giving me anything useful. Let me check it out. Well, I don't have signal going into it. Let's have the actual audio signal as it is at that point going through it. Well, now why am I getting such a high amplitude? I mean, I'm adding these two signals together, but when one's down, the other's up, and when the other's up, the other one's down. Hold on here. This is bizarre. Let me check its properties. Yeah, I'm displaying 0 to 1. Oh, I know why. Yeah. Okay. We're going to have it display -1 up to 1 again. Because we're displaying the actual waveform, we do need the full range of it. If we were just displaying what the amplitude modulation module was doing, like if we were coming out of here, then we could have the range of 0 to 1 on the table. But since we're displaying full waveform, and now let me do this. Let's go to 5. Now, of course, if you wanted to, you could take another MIDI controller in if you have a controller with knobs on it, and have that MIDI controller number come in here. You'd have to convert the 0 to 127 range, like we did with the modulation here, to a different range, like 0 to 1 to control the amount of tremolo. You could even control frequency here, but you'd have to do, some value changes so that 0 to 127 would be converted to a range of whatever frequency values you want to have here. Another thing that could be done is if you don't have some controller knobs, you can make a switch system. Just kind of like here where you switch between different oscillators, you could set up that to switch whether modulation controls filter or whatever. But in any case, we can make some interesting sounds already. When we get our other row in of controls, we'll definitely be able to do more. But as it is right now, let me take a screenshot. Maybe let's make this 10. Turn the amount down. Yeah, let's take a screenshot. All right, well, thank you for joining me this week. Please don't forget to hit the like button since you've been with me so far. And subscribe to help me thrive. That sort of stuff. Here we go. All righty. So now we see amplitude modulation. And we basically can do tremolo as well as ring modulation on our synthesizer now. And there's still more to come. See you then as we do it. It's going to be an adventure. It's going to be an adventure. All right, there it is. Take care.